thank you so much for inviting me to be part of this just fantastic event. I think, as many of you, I didn't have a chance to grieve Emmanuel's loss, so it's very important that we are here all together and share stories and remember him. So I just want to say just quickly a few words before I start. We said a lot about his brilliance, excellence, drive to be perfect, but one thing that wasn't mentioned is that despite the fact that he put himself, pretty much the standards he put for himself were very high, with respect to his students and friends, the advice he gave, actually he prioritized often their happiness over their professional success. So I want to give an anecdote that's quite personal, and Gita is here, so she knows well about it. So when I was a fifth year at Harvard, so both Gita and Emmanuel were my advisors, and as Gita remembers, I had reached a point where I just had to graduate, but I was not ready at all. My paper wasn't ready, I wasn't ready. So naturally, Gita and Ken and Jeremy at the time advised me, okay, stay another year, polish your paper, why are you taking this risk? Which is the advice any good advisor is going to give their students. But when I went to Emmanuel's office, at that point I was kind of reaching desperation levels because I didn't know what to do, and I felt the need that I just had to graduate that year for personal reasons. And Emmanuel just looked at me. He's like, okay, your paper isn't ready, but I get it. You have to graduate and I'll help. And I started crying. So this was, at that moment, when I really needed him, he was there. Sorry. Maybe I should have shared it clearly. But I just want to show that he actually put happiness in front of everything else for the people he cared about. And that's the message I want to give. So this paper is actually joint work with Jenny. So Jenny is also a student of Emmanuel, and she really regrets not being able to be here with us, but she's heavily pregnant, which is why she's not here. And another piece of advice that Emmanuel gave us, and he prioritized our happiness, was don't be strategic regarding your quarters, right? So we graduated 2013, 2014, and I still remember we went for a run with him along the Chaires, and we were sitting, and he was like, when are you going to start writing papers with Jenny? Because we were best friends in grad school. And he kept pushing us, you need to start writing papers together. And at that point, actually that's the summer when we started working together, and we never stopped. And indeed, in terms of strategically, we had 4 kids in 6 years, so productivity-wise wasn't the best decision. But honestly, I can say that if I wasn't working with my best friend, I might not have stayed in this profession. So it was one of the, again, most important pieces of advice he gave me. So I just want to kind of conclude, because there are PhD students in this room. So I want to kind of change a little bit the message, the kind of advice that Emmanuel might give us in the following way. So I think he would advise PhD students, reach for the stars, tackle the hard questions, push yourself, and enjoy the beautiful journey of exploration. However, do it at your own pace and prioritize your happiness. So that's what I want to leave with. I just have a sip of water. But I hate to say it because there are PhD students in the room. And this profession is very challenging, I'm not going to lie. And we have experienced it for different reasons. So let's start now. So the topic is individual beliefs, demand for currency and exchange rate dynamics. So actually, this paper has a motto with deviation from full information rational expectations. Neither Jenny or I were interested in deviations from FAR in grad school, and the reason why I ended up working on that is because the data brought us there, right? So we kind of followed Emmanuel's example, which is start with a question, follow the data, follow the intuition, and just pursue it. So the way we see this paper is just another stop on our journey of exploring exchange rates. So let me tell you where we are in that journey, which is still work in progress, of course. So what do we do in this paper? So the motivation is quite standard for the exchange rate literature. So we all know that exchange rates, as any other market-driven price, are determined by supply and demand. However, we don't understand well the beliefs of the marginal traders of foreign exchange, which are the main driver of demand, and as a result, realized exchange rates. So there are 2 main contributions of this paper. So I mentioned that we're going to rely on survey data on exchange rate expectations, and we are going to use that survey data to discipline the theory. And why survey data, right? So actually, I remember a discussion with Gita in 2014 or 15 when we started working with this survey data, and you kind of said, isn't, kind of garbage, the survey data? And to be honest, you were not the only one that was asking us this question. Many people were telling us, why should we care about the survey data? So our mission became to persuade people that the survey data wasn't garbage. So that's bullet point 1. So what do we do? So the first part of the paper, we're going to show you that the consensus economics, in particular exchange rate forecasts, are consistent with the average positions of the OTC Forex traders, right? So the over-the-counter market is the biggest market where exchange rate derivatives are traded, and the derivatives comprise 70% of the Forex markets. So by showing you that the average OTC Forex derivatives positions are consistent with the consensus economics survey data, and they're not consistent with FIRE, then hopefully this will persuade you that it's worth studying this type of data and understanding it better. So in the second part of the paper, we're going to take the data seriously. We're going to build a model that is going to be both kind of general in some dimensions and very simplistic in others. So the dimensions in which it's going to be general is we're going to allow for a variety of forms of deviation from FIRE that people have worked on, because we want to let the data speak. So we're going to estimate the model, and we will let the data tell us which type of deviation from FIRE actually matters to explain both the survey data and realized exchange rates. But it's going to be very simplistic in the way we model the real economy, just because we need to solve it in closed form in order to estimate. So once we estimated this model using individual level exchange rate expectations, we're going to show you that we can explain a large fraction of the variation of exchange rate survey data surprises, expected and realized exchange rate changes. And moreover, based on the estimated parameters, we'll be able to explain a number of exchange rate puzzles that people have recently, particularly some of them more recent and others older. So for example, the Dornbusch delayed overshooting puzzle, which is one of the older puzzles, the forward premium FAMA puzzle, and what's called now the return predictability reversal puzzle. Some of you know it as the Engel/Bochev puzzle. And also you can generate the forecast revisions regression results in Bordalo, Giagnoli, and Schleifer. So let me jump straight in. Literature review slides. Last night I spent half an hour on this after someone mentioned it. And the fact is I'm still missing probably 80% of the papers, but also it's only one slide, so please don't kill me. But essentially I did try to put most of the more recent papers. Of course, it's a vast literature. So in terms of deviations from FIRE and survey data, let me tell you a little bit how the recent literature has evolved, particularly the empirical literature that does use survey data on expectations. So the attempt has been to match the survey data, in some dimensions, but people have focused in one type of deviation from FIRE, right? Maybe the agents don't know the persistence of the monetary policy process, or there is a very interesting paper actually by Angelettos and a co-author in the MBR macro annual, which is quite closely related to what we're going to do here. So we want to take the approach of let's introduce kind of a variety of these deviations from FIRE that people have considered and let the data speak, and we'll tell you which ones seem to matter the most. And then it will be linked to the intermediation-based exchange rate models that all of you know very well, in the sense that this is the type of model we're going to write as well. And then it will be linked to the literature explaining exchange rate dynamics and puzzles. So let me jump straight in. So this is a picture that...
So there's another bit by Schleifer and Giagnoli, right? So it's like related to Angelettos work. So they are making this point that when you use this survey-based expectations using the aggregate average consensus one versus the individual one, that also makes a difference and can tell you what type of friction on the...
Yeah, so we're going to use the individual data. We're going to do, for the estimation, we're going to use the individual level expectation.
But you're going to tell us a different result if you use the aggregate one, or not?
So we replicate the results, so I can tell you that. I will not have time actually to show you, but their result in the AR paper with Uran, we replicate it for exchange rates. So I can tell you that it holds, so I know you don't have the individual level exchange rate data, so we replicate it, and we replicate it, essentially. Actually, I will not have the time to show you this result, so I can tell you a bit more later what matches that. So you have seen this picture before, and I'll tell you first, what it is and how it deviates from your classic intermediation-based asset pricing model. So you have two types of you have a representative agent in each country. So you have a home consumer and a foreign consumer that are trading with an intermediary that we call financier here. So they're trading it in local currency bonds, one period local currency bonds. So what's different is essentially now we introduce also the derivatives market, and I'll tell you, why we need to introduce this here. So on the one hand, the financiers, which is effectively, think of them as everyone trading in the over-the-counter market, which is where the forex derivative market is made. So they trade forward contract with each other, and moreover, there is another market, which is the futures market, and there's a separate group of agents that participate in that market, and we call them speculators. Let me preempt why we need to introduce this complexity. Why do we need to model the futures market? So some of you might be aware that the futures market is only 2% of the total forex market. So as you can imagine, for general equilibrium effects, it's not going to matter, the calibration. Even if I shut that down, I'm going to get pretty similar results. The reason why I introduce it is because that's where we get data on the average positions of the OTC trader. So it's actually publicly available data. Anyone can download it and replicate the regressions that I'm going to show you here. But the futures market is going to give us a glimpse in average positions, which we can link to the expectations of the average OTC trader. That's why we need it here. Right, so what is the model? So this is the problem of the home consumer. They maximize consumption, money demand, and the amount of bonds that they purchased. And then there is a demand shock indexed by Zeta, Xi, Elias? Here's my Greek letter. It says Xi or Zeta. I'm the person that never knows. Xi. Great, thank you very much. Xi. Log consumption, and then they derive utility from real money balances. So this is the budget constraint. So on the left-hand side, you have the amount of the money demand plus the demand for bonds in the period, plus the amount they need to spend on the consumption basket. On the right-hand side, you need you have the purchases of the tradable good, the purchases of the non-tradable good, plus whatever they received from their old bond holdings. And moreover, we assume that the profits from the financiers and the speculators accrue to the home consumers. We're going to linearize the model, so these terms are going to be second order. And then we use the tricks similarly to Gabag and Majori, where the money supply is just given from the central bank within the same period to the consumer. You have the Cobb-Douglas aggregator for aggregate consumption, and this gives you a very simple home consumer Euler equation. So technically, in this model, we're going to, whether you assume an exogenous process for the interest rate or for the money supply, is going to be equivalent, right? We're going to be working with the money supply, but the mapping is going to be one-to-one. For simplicity, we're going to assume that the consumers have expectations consistent with FIRE. This is not crucial. If you prefer to think of just having an exogenous process for the interest rate, you can work with this. All right, so now the financiers. So what do? So there's measure one of financiers who live for one period and they have no startup capital. They have mean variance preferences over end-of-life nominal profits. They trade both derivative contracts and the bonds denominated in both currencies. So here, ETFI is going to be the subjective belief of financier I. ST is the nominal exchange rate, which is going to be defined as foreign per home, where for us, home is going to be the US. And FT is going to be the futures price, defined in the same way. So BTFI is the foreign currency bond holdings of financier I, and similarly for home currency bond holdings. So XTI is an important variable. So this is the notional foreign currency exposure of financier I denominated in foreign currency. So what is that? Right? So when you're entering a foreign exchange or derivative contract with someone, like a forward or a futures contract, you promise to exchange XT units of the foreign currency against a certain amount of the other currency, right? And the relative amounts give you your forward rate. So this is where the data will be. So we'll be working quite a bit with XT here. So at the end of the day, with mean variance preferences, this is the Euler equation that you're going to get. So notice here that RT/BT plus XT is your total foreign currency exposure, or the total amount of foreign currency that you're going to receive in T+1 as a financier. Rho is your risk aversion, and sigma S is the subjective exchange rate variance. In this model, actually, CAP is going to hold. And the financiers are indifferent between short-long positions in bonds and using futures contracts as a result. So only the joint portfolio is going to be pinned down here. Right, so now, these speculators. So we do need essentially to model their demand in order to close the model. It's going to be done again using mean variance preferences, which is going to give you the following Euler, and there is a measure M of them, which will be calibrated to be 2% of the market, as it is the case in the data. So let me tell you a little bit how we're going to model their beliefs. I will not have time to go into detail, given that I want to show you the more interesting stuff. But it appears that in this market, so in the futures market, which is fairly small, the agents that are trading futures exchange rate derivative contracts primarily follow momentum strategy. So, there are papers that have shown that. We also documented it, using our own work. So we're going to model their beliefs to be consistent roughly with momentum. Right? So in a vein similar to a paper by Stein and Hong, we are going to simplify it even a little bit further the way we model momentum, because we need to solve everything in closed form. But just essentially this will be the assumption that we're going to make on the ETS later on. Right, so let me start with the interesting stuff. So I promised you that we'll be able to use this futures data that is publicly available in order to tell you something interesting, despite the fact that it's a tiny fraction of the market. So the reason why it's useful is because it's split in an interesting way. So everyone can download the CFTC Commitment of Traders reports for the United States, and then they classify the traders into hedgers and speculators. So what are the different categories? So the hedgers category is almost entirely represented by the dealers category. And the reason why we know that is starting 2006, they also started doing a more detailed classifications in the traders in financials futures reports, where there is a separate dealer category. So if you plot the dealers against the hedgers, you're going to see that the two series pretty much overlap. That makes sense, because these are the market makers, right? So the way the market operates is that everyone, pretty much the majority of the financiers are going to go to the OTC market, to a market maker. They're going to trade forward contracts with the market maker, and the market maker of course has to clear the market, right? However, the futures market is very liquid, so they are going to use the futures market to clear the market, because at every single point of time they have to have on net zero exposure. So actually the big currencies, they clear within seconds, right? Maximum 30 seconds. Effectively, they can achieve this zero net exposure. So essentially, these market makers, they're a shell, right? They're a shell in this market. So when you look at the hedgers' positions, in a sense, you're looking at the average demand for foreign currency futures by the average OTC player, right? So everyone is netting out all the forward contracts with each other in the OTC market. So you've netted everything out. Whatever is left in the form of demand is the demand for futures by the average OTC trader, and this is captured by this effectively hedgers category. And I have a quote of essentially how they interpret these hedgers, which is very much in line with their capturing these market makers. We have 7 currencies, the 7 liquid currencies, because this is essentially where the data is. Right. So let me tell you about the survey data. So we're going to be using the consensus economics exchange rate forecasts, and we were lucky enough after more than a year of negotiation with them to make them sell to us the individual level exchange rate expectations for these 7 currencies. So we are going to restrict the sample to forecasters that have at least 24 months of data, and this is going to give you a maximum number of 42 forecasters depending on the horizon that we consider. And we are going to exploit all 4 horizons. So there will be 2 sources of heterogeneity, both the forecast horizon and, of course, you have the individual level forecasted. And that's what's going to give us the identification. The sample is monthly series from 1997 to 2020, and this is the same set of currencies. Now, let me tell you with the promise I made, what do I mean that the consensus economic expectations are consistent with positions, right? So given the interpretation I gave you regarding how you can interpret XT, such as the average demand of the OTC trader for foreign currency futures, remember our Euler equation here, it was a function of precisely this average demand of foreign currency futures plus the demand for foreign currency bonds. Granted, in the regression that I'm showing you, I'm not controlling for BTF because it's very hard to measure. We have tried to proxy it using the BAS data, and if you do use the best measures from the most confidential level of BAS data that you can get, our results remain. But we do not have, unfortunately, a fantastic proxy of BTF. So we are going to use only XT in the regression, and then we have a measure of the expected excess return using the consensus economics expectations. And that's what I'm showing you in these regressions.
So you have CIP holds all the time, because these guys clear all the time, there's no problem of not finding features or any
Yeah, there are no CIP deviations, yeah.
Right, so but you have UIP deviations.
Yes.
Okay, fine.
Yeah.
Then in the data, you check this and there's
Yeah, the UIP deviations, you're subjective.
UIP, fine, I'm fine, but the CIP deviation, because we know that.
Well, so we had a version of the model. So
very little.
They're very little, right? So they're second order in the sense of we had a version of the model where we allowed for CAP deviations and we allowed for the CAP pretty much variable. We put it in the model to see whether we can improve the fit. We didn't really get much out of it, so we just simplified the model in that dimension. We might revisit it at some point, but we didn't find it at the time to be first order empirically. That's why we killed it. Okay, so how do we show that positions are linked to the expectations? Well, on the left-hand side, you have this average futures derivatives positions of the OTC trader, and on the right-hand side, you have the expected excess return. And then if they're consistent, this is a correlation, this is not causation, we do not have an instrument, I want to be very honest here. So if the data is consistent with these expectations, you're going to have a positive and statistically significant condition, and that's what we find. So we have split the sample before and after the financial crisis because there is a structural break actually in the constant, interestingly enough, primarily. But even in the coefficients, as you can see, and you can find that it's highly statistically significant across all currency crosses. I can show you that it's going to look very similar in terms of significance if you use not just the 1 month ahead forecast, but also the 3 month, 12 month, and 24. So it is robust to the forecast horizon. We've done some robustness checks that if anyone is interested, I can tell you later on. Now, how do we test whether the positions, this XT, is consistent with FIRE? Maybe, FIRE is also consistent with XT. So how can we do that? Well, we're going to take the standard finance approach where you put the realized excess return on the right-hand side, and then you're going to put XT on the right-hand side. So given that the rational surprise should be orthogonal to period T information, this is effectively an identified regression. However, we find that the estimated coefficients are pretty much close to 0 and not significant. So this is telling us that particularly this measure of positions, which is the average OTC trader holdings of futures, is not consistent with rational expectations. So, yeah.
So I guess I missed that. So what should the model imply about beta? Just its sign, or also its value?
Yeah. So the magnitude here, I'm not telling you anything about the magnitude. Of course, this is a function of parameters. So if one wants, you can take the model seriously. But at the very least, we know what the sign is. It has to be positive, and you would hope to be statistically significant. Granted, we're not controlling for B, so there is some immediate variable bias. We've tried to control for the best measure we can find of B, and the results remain. But it is correlation, it's not causation. I'm upfront about it. So this hopefully kind of gives you some kind of motivation of why it is useful to study that data. And now let's take it seriously and study it. So, yeah?
On the regression, I understand why this is a test of FIRE, and maybe this is what you're doing in the models, so just feel free to differ. But I would have thought, even if this says FIRE doesn't hold, I would have thought in this class of models, the positions must induce movements in exchange rates to clear the market. And so you should still expect to see X having effects on exchange rates and then leading some predictability for returns. Is that, what I'm saying?
Well, so XT, we do have regressions where we find that the change in X is correlated with the change of exchange rates. And we do have adjusted R-squares of 30%. Now it's hard to interpret that in a no-structure way because the market is zero net demand, right? So the fact that the correlation is positive for agent 1 means that it's negative for agent 2, right? By definition, you're always going to have this issue. Yeah, so if you do correlations of the change in XT and change of exchange rates actually even at 3 months, 6 months. So the order flow literature tells you that relationship between order flows and exchange rates tend to be there at very short horizons. We find it even at higher horizons. But the no structure interpretation is not very neat, right, of this. I can show you maybe later as well. So I'm not going to present these regressions here, but yes, there is a correlation there, definitely.
I'll ask a super stupid question. Why is beta FIRE greater? Can you just explain very simply why beta should be, why that coefficient should be positive under FIRE?
Oh, so essentially it just comes from, we're just testing the Euler, right? So we do not, unfortunately, have a good measure for B, right? So there is some immediate variable bias. If you take this Euler seriously, right, then effectively there should be a correlation which is positive between your measure of the expected excess return, and of course you need to take a stand. If it's under FIRE, you need rational expectations. If it's deviations from FIRE, you need to pick your measure of subjective beliefs. So you can decompose, right? You can say that this rational expected excess returns are equal to the realized excess returns plus the rational surprise component. And the rational surprise, by definition, has to be orthogonal to period T information, which is what makes this regression an okay test of fire. Right, so let's solve them all. So how do we do it? So now is I have to explain to you what type of deviation from fire model, which is the hard part. Right, so this is effectively what the solution of the model looks like. We can solve it in closed forms. You have the budget constraint on top, you have the Euler for the speculators in the middle, and at the bottom you have the Euler for the financiers. So the tilde stands for foreign minus home. You have an exogenous process for the money supply, which is pretty much the same as an exogenous process for the relative interest rates, an exogenous process for the demand shocks, the TFP shocks, and then NX stands for net exports of the home consumer, in this case, the US. So now on the rational expectations, this is what the linearized solution looks like, right? And then you can solve in closed form for these parameters. So let me show you now what is the deviation from fire that we assume. Right, so this is the perceived data generating process of ST plus 1 by financier I. So what are the components? So there could be deviation from fire in 3 different ways. So first, they might not observe the true parameters in the data generating process. So essentially the little psi is the true parameter and psi hat is the perceived parameter in the data generating process. Then they might not know the true persistence of the shocks, right? So rho is the true persistence, rho hat is the perceived persistence. And then finally, they don't observe demand. The demand is a latent variable, so they receive a signal of latent demand. What does it look like? So this is what the signal looks like, and this is psi, I think. Is equal to 0 plus the loading of the forecaster on mu, and I'm going to tell you in a second what mu is, plus idiosyncratic noise. So what is this mu? So we allow for sentiments in the spirit of Angeleros and Quarters, right? Effectively, your noise in the signal could be correlated. So this is what this mu captures. And we want to let the data speak, right? The data is going to tell us what this alpha is, we're going to estimate it, is it important, this mu or not. That's how we can think about it. So we do allow, in a sense, for sentiments as well. So once again, there is an IID, this epsilon is the IID noise across forecasters and over time. And forecaster I is going to believe that she sees the true demand shock. So she's going to believe that psi is equal to zeta, and the forecaster is never going to observe the true demand shock. So this is stark simplification, right? You can do Bayesian updating, you can do something more complicated. Yeah?
So just to make sure, you're imposing a belief process on an endogenous variable in your model, which would be exchange rate, right? You could have imposed right? Is that what you do?
Yeah, so a lot of the literature, what they do is they say, okay, they know the phi's, right? They know the true parameters in the data generating process, but they don't know the rho's, right? Which is effectively an exogenous parameter, because this is the persistence of the exogenous shock. So this is a big chunk of the literature would take this approach. There is another literature in the spirit of the work by Marcet, which is much more sophisticated than that, right? Because they have endogenous learning over the parameters in the data generating process. So this is a simplification, if you wish, of that work by Marcet and Quarters, where they don't know the true weight in the data. Indeed, endogenous. It is an endogenous variable. You're absolutely right. So it's in the spirit of this literature, and it's very simple because we don't have any endogenous learning or anything like that, right? They just don't know.
So I meant something much simpler. So imagine that so you have you would imagine there's a process, let's say for interest rate differential, which would then pin down the process for the exchange rates.
Yeah.
Now you could have assumed a behavioral model or mistaken beliefs about the interest rate differential, which is you treat that as your exogenous variable. But that would induce a belief on the exchange rate.
No, we do that, right? So this is captured in the raw, right? We do that. We actually capture the majority of the deviation from fire forms that you can imagine, because once again, this is our exogenous variables. So you little.
I don't know where you're pointing. So.
Yeah. Sorry. So where's the? Yeah, perfect. Okay, right. So this is the exogenous process for the money supply.
Okay.
It's an exogenous money supply shocks, which maps 1-to-1 to the interest rate. So you can think of it as an exogenous process for the interest rate. So then you can have a version where they don't know the true rho, and it's just captured by rho hat, right? And we'll be estimating that in the data to tell you how far away the true rho is from the perceived rho, right? And so a lot of the papers actually do that, and then we allow it for you can put it on any shock. And there'll be actually 4 with the sentiment, there'll be 4 shocks in the model. And then on top of that, we want to speak to the literature kind of in the vein of Merced and Cotter's internal rationality stuff, where you don't know the actual parameter in the data generating process, and then we're gonna stop of the exchange rate, right? It comes from here. So we assume the following process of beliefs, a forecaster.
If you assume a belief process for the interest rate differential,
for everything.
you should pin down the belief process for the exchange rates. No, I mean, how can
okay.
Are they not related?
Yeah, they are. So wait a few slides, and I'm going to show you how the model is solved.
Okay.
Right. So now we are specifying what are the beliefs of agent I. They could be anything. They could be random noise. They could be garbage. Right. So this is an exogenously assumed process of the beliefs of agent I, and essentially you can see that it does relate to the rational expectation solutions in the sense that you have the same number of shocks. They just don't know potentially the weights on these shocks, and moreover they do not know potentially the rho's. And then finally they don't observe this demand shock, they observe a signal, and the assumptions here is that first there is a sentiment component, so the noise is correlated, so this is this mu, and moreover we assume that they're infinitely overconfident, in the words of Angeletto, so the perceived precision is infinity of the signal, right? And this is just for simplification. You can do Bayesian learning, like it's a mess. We have to solve this in closed form in order to be able to estimate it. That's where we're going here. But you can see that you can do pretty well with this. So then once you do that, this is how you can rewrite once again, this is the functional form we assume for the expectations of agent I. Right? So how do we solve the model? So that's what you're asking. So let's do that. So we can take the average across all the forecasters. So here the assumption is that each participant in the OTC market has some belief that is consistent with this, and then we can calculate the average of that, because that's what we need to put in the model, right? Because this is our system of equations, so we need the average belief, which is the EF tilde. So this is the average subjective belief. So now we are aggregating over all the beliefs of the little i's, and this is what you get, right? Given that we assume that this noise is ID over the forecasters. Now we can obtain closed form solutions for the parameters. Now this is the true data generating process, and we'll be solving endogenously for phi s, phi m, phi mu, phi a, and then the rest of the parameters in the data generating process as a function of the average perceived data generating parameters and as a function of the deep model parameters. Does this make sense, right? So you're plugging in this average, this model of average expectations, which could be anything. It could be noise, it could be whatever you want it to be, right? So this is the functional form you assume, and then you solve your model in the standard way, right? So this is, so once you solve it, right? Once you solve it, then you can, and then we do need an additional assumption of how do they form their expectations over the future values of the signal which they believe to be the true demand shock. So we do need an additional assumption on that, because we need to write the expressions for the expectations and periods ahead, right? Thank you. So you can solve in closed forms your subjective, what the subjective belief of agent I looks like, where effectively it is solved out as a function of either the perceived parameters in their data generating process or the true parameters in the model, and then your rational expectations expectation of the exchange rate, right? And then everything again is a function of you can solve out for all these phi s, etc. as a function of the deep parameters. So now that's the interesting part, I think, of like what do we do with this, right? So we have this expression. So how do we estimate that now the model? Well, we don't observe the psi and we don't observe the mu. So these are unobservable variables. So how do we go ahead to estimate it? We try to proxy these variables using observable variables. So we use a measure of net exports, bilateral net exports, because this is what this comes out of one of the equations in the solutions. So notice we have net exports here, right? So if we have a measure of net exports, you can back out the demand from here. And moreover, we also can use the average or the consensus economic expectation one period ahead to back out your latent demand mu. Again, as a function of all these parameters that you have solved out for as a function of the d parameters you'll be estimating. So once you have that, then you can rewrite your expressions for the expected exchange rate, the subjective expectations, and the rational as a function of observable random variables and these loadings that we have closed form solutions for. And moreover, now I'm going to tell you what are the moments that we're going to be matching.
But wait, why are you doing the financier specific?
The I, yeah, so this is the, oh yeah, I dropped the, sorry, I forgot the F, it's a typo.
You're not doing that, you're using financier specific.
Yeah, so there should be F, comma I. It's a typo. Sorry. Yeah, because you have the noise still there, right? The noise enters. So what are the moments that we're going to be matching in the estimations? So notice that we can express the realized exchange rate changes. So this is and then we're going to be using the horizons 1, 3, 12, and 24 as a function of these observable variables, the parameters, and the rational surprise. And the rational surprise has to be orthogonal by definition to the period t variables, right? And the second equation we're going to be using is the expected exchange rate using the subjective beliefs, where the only component we don't observe here is this idiosyncratic component, which by assumption should be orthogonal to the period t variables in the model. So we're going to be essentially minimizing the mean squared error of these equations, and that's how the model will be estimated, and you can also back out the surprises. So what I'm going to show you is once we estimate it, how much can you explain of the variation of the expected exchange rates, the realized ones, and the surprises. So let's do that, right? So this is what we do. So I'm going to show you the results where I assume that actually the perceived parameters don't vary by I. We've done it, we've allowed for heterogeneity. Actually, the dispersion, interestingly enough, in the estimated parameters is not huge. So this captures pretty well how far you can go in terms of explaining the data, allowing for the little phi and the little rho to have the I subcomponent doesn't buy you that much, actually, interestingly enough. So as both the idiosyncratic noise in the signal and the rational exchange rates are price orthogonal to the period t aggregate observable variables, we're going to estimate the model, but by minimizing this mean squared sum of the following moments, where we have the closed form solution of the taus as a function of the perceived data generating process parameters and the deep model parameters. We're going to calibrate a few parameters, such as we're going to make the size of the futures market tiny, to be consistent with the data. You can shut it down completely, nothing is going to change, and we're going to estimate the model currency cross by currency cross. So this is your theoretical R squared from estimating that model, right? So what do we mean by that? Well, this is how much you can explain from your subjective surprises, right? So this is your expectation using the consensus economic survey data minus the realized exchange rate end periods from now. Your expected exchange rate, again measured using the consensus economics expectation. This is the individual level ones, and then your realized exchange rate changes you have in red. And what do I mean by, what is explaining, what is this capturing this theoretical R squared? Well, this is the fraction of the variation that is explained by the lagged exchange rate ST, AT we proxy with industrial production, which I didn't mention, apologies. MT, of course, we proxy with the relative interest rate differential, net exports with net exports, and your average period one ahead consensus, thank you, economics expectation. So you can see that we can explain a big chunk of the variation of the surprises, expected exchange rates, and even realized exchange rates at higher horizons, right? So if you look, this is your mean across countries, your average across countries. So if we start with the expected exchange rate, even at short horizons, we can explain as high as 30%, at 24 on average, 40% of the variation of the expected exchange rate. With the subjective surprises, notice that the residual there is both the idiosyncratic component and the rational expectations component. So given that this could be quite volatile, we still managed to explain a significant fraction of the subjective surprises. And with realized exchange rates at 12 months, on average, it's 22 or 23% R square, and at 24 months, it's more than 40%. Just those 5 variables. I can share with you some countries. So for example, this is Germany. They look actually quite consistent across different countries. This is Australia. Now, let me show you what are the estimated parameters, right? You might wonder, where is the deviation from phi? So that's what I mean by we let the data speak, right? Here it's a bit of a fight. Is it a deviation in the phi's? Like Merced style models, is it the deviation in the rows? A lot of the people are pushing the deviation in the rows. Notice the difference between rho and rho hat. It's tiny. Actually, the perceived rho that is needed to explain the data is quite close to the estimates of the true row. So if I kill this, if I force the model, essentially if I assume that rho equals to rho hat and re-estimate the model, the results are going to look pretty much almost exactly the same. Where the difference is in the phi's, right? So the model wants that the true phi's, the true loadings in the true data generating process are very different from the perceived ones, from the phi hats. So you can see that particularly for the exchange rate, it wants to make the loading on the lagged exchange rate very persistent in the true data generating process, while the perceived is very small, right? And then you can compare it to the rational expectation case. Notice that in the rational expectation, so the deviation from hierarchy gives you significantly more persistence relative to the rational expectations case. So this kind of gives you a little bit of an answer of, if you want to pick and choose between these two forms of deviation from fire, it seems that actually what the data wants is effectively we don't know the true parameters in the data generating process. Now, hump shape dynamics. So essentially, this is the Dornbusch overshooting puzzle with respect to monetary policy shocks. What does it take to get this hump shape dynamics? So this is the derivative of the exchange rate change between t plus k minus 1 and t plus k with respect to the deep shock. It has to be first positive and then negative. That's what gives you the hump shapes. And then I'm plotting it against the rational expectations in red, which you can't get in this model. Now this Engel-Volchev puzzle. So actually, all of these puzzles are linked to hump shape dynamics, right? I mean, they have different names, but they're kind of closely related. Let's put it this way. So what is this puzzle? Well, we defined with lambda the realized excess return. And here, it's indexed by t plus k. So it's the realized excess return between t plus k minus 1 and t plus k. And we regress that on the period t interest rate differential, or just the exchange rate change over these horizons. And one I've labeled as the pharma beta, and the other one is the UAP beta. And then the theoretical expression is a function again of these impulse responses, right? These derivatives of the change in the exchange rates with respect to the monetary supply shock. And notice that without matching the Dornbusch overshooting puzzle, you can never match this Engel-Volchev puzzle, right? So once you match the one is a necessary condition to match the other. So this is what it looks like when you estimate it in the data, right? So this is the using the projection method, the estimates, that we get in the data for the pharma and the UAP, and this is what the model delivers. So here we have Australia, here we have Germany, so you can easily match this puzzle as well. And I can tell you that if you estimate the model just allowing for deviation in the rows and you estimate it, you cannot get this. You're not going to get the hump shape, and you're not going to get this puzzle. Right, so conclusion, so we build an estimated general equilibrium model that allows for deviations from rational expectations in a way consistent with forecast survey data and traders' assets positions. We show that the model explains a large fraction of expected and realized exchange rate changes and survey surprises. And we argue that the particular form of deviation from FIRE implied by the data can help resolve important exchange rate puzzles. Thank you very much.